resubmit the AC, okay? Just leave it. I will mark it, okay? Applying exponent class. Evaluate the following. Evaluate, right, is like calculate number, right? You're gonna have to actually come up with a number when you see evaluate. In general, that's how it works. So in case you're wondering, what are we doing now? I will show you that we're gonna apply, and you have a yellow handout like this. We're basically applying our knowledge of all of these, okay? What happens when things are side by side? You add up the exponents. When they're like this, you subtract. So if you're consistent, right, negative exponent, we flip, right? If you're consistent, this is the one that most students forget about. A power of a power, you multiply them, okay? If there's something outside and inside, you multiply the exponents, okay? So that's what we're going to cover, but I'm going to go step by step here, one example at a time. I can tell you this, that there are many ways of doing this. Okay, there are many ways of getting to the final answer. Some are easier, some are make it more difficult. Okay, so you have to think that whoever, when I design these, I design them backwards. Like I'm like, this is what I want, and so I just add layers to it. So somehow you got to get to a pretty simplified final answer, and especially if it's evaluate, you want a final number. Okay. So here we recognize, first of all, focus inside. Doesn't matter if they're square brackets, right? Some examples will have square brackets. They are the same thing as round brackets. Okay, we focus on the inside, and we notice that these have the same base. And they both have fractional exponents. So here you have to be, your knowledge of fractions come in, right? So you take 5/2 minus 1/2. All of that is still squared. So don't forget to include what's around it, right? Some students, they just drop things, right, along the way. So same base, so we can subtract. And then in this case, they have the same denominator. So it's really just 4/2, right, left, squared. I would try to simplify this, right? 4/2, that's just 2. All of that squared. So here it's 3 to the power of 4, right? You recognize that, that's 3 to the power of 4. And that is really 3 squared times 3 squared, which is 9 times 9, which is 81. Okay, so that's your final answer there. You've evaluated that expression. B, let's do, I'll add more to it. Similar situation. So again, we're starting with the inside, we notice that all three numbers have the same base. These could be decimals, folks, right? If these are decimals, the same thing applies. I showed you one example towards the end of yesterday's lesson, right? Same base, same property applies. So we're going to go 9. We're going to take 5 over 4. We're going to add, because when you multiply across like this, you add, right? Negative 1/4. And then you subtract the denominator, the exponent that is in the denominator, you subtract. That is very important, right? So you add whatever is multiplying here, you subtract the denominator. And that whole thing is still squared. And now we can probably simplify because they're all quarters, right? So this is 5 minus 1, right? That is 4. 4 minus 3, that is just 1. 1/4 squared. Now, you have to be careful here, right? Remember, fractionals are really radicals, they're roots, right? Can you take the 4th root of 9? Doesn't look like it's going to go anywhere, right? Then I want you to look at the two exponents here, and what happens when you have exponent and exponent? What do we do with these? We multiply them, right? So that's what we're going to do. 9 1/4 times 2, like that. And that is just 9 2 over 4, right? Because 1 times 2 is just 2. 4 times 1, the 2 as is 2. That is really 9 1/2, isn't it? If you reduce the fraction here. That is square root of 9, which apparently I forgot how to do. I didn't know that square root of 9 is 3 earlier, right? But there it is, it's 3. You don't need to show me that many steps along the way, but I'm showing you, right? Like, because later you go back to your notes, you're like, what happened there, right? It's like, well, okay, we multiplied these two. We got 2 out of 4, that was half, and that is the same thing as root of 9. So as you can see, if you would have taken the 4th root of 9 here and then squared it, you would have ended up with a dead end, right? So you have to, when that happens, look at, okay, let's multiply these two and then move forward. Okay, let's try another one. Um, I just made this one up because I want you to have a complicated example. I'm just checking something. Yeah, we're gonna turn this into a negative here. Can you please make sure you have a -3, or else this will be a huge number. I don't want that. So we're still evaluating under these circumstances. Lots of stuff happening, right? You notice negatives. You notice a negative outside, and that's a fraction, right? Don't be overwhelmed. Focus on the inside, right? So all the same base. For now, I'm going to keep it as a decimal. You can change that, but I'm going to keep this as a decimal and just focus on the exponents. I'm collecting like exponents, right? When you have all three the same base, you can deal with the exponents all in one shot. So you go 2 plus -3 minus, what happens here? What's the exponent in the denominator? It's -2, right? So you have to make sure you take that into account, because it's always, right, top minus the exponents in the denominator. All of this to the -1/2. Now what? 0.09. This would be 2 minus 3. Negative and negative will turn into a positive, right? These two turn into a positive. And that's +2. Okay. And then you get all of that is still to the -1/2. Okay. And at this point, I will start turning this decimal already into a fraction. So that's 2 decimal places, so that's 9/100. If you do the math here, this gives you -1, right? Plus 2 gives you 1, right? 1 positive, so we don't need to put that there. All of that to the -1/2. Like that. So we cleaned up the exponents. Now I also turned my decimal into a fraction because I'm ready to work with it. And this only turned out to be 1, okay? So that's, this whole thing has an exponent of 1, which we don't need to write down. And now you apply the outside exponent. So we will flip it like this. And now we take the square root of 100/9, which is 10/3. So this is the evaluating type of scenarios. Okay, simplify the following. So here we have 50x squared y to the 4 over 2x to the 4 y to the 7. All of that to the power of 1/2. As you're writing this down, okay, when we do ACs and you feel like, oh my goodness, I bombed this, right? I don't want you to give up, okay? I don't want you to feel like, just take it as a learning opportunity, move on, right? Learning opportunity, move on. I want you to stay in the race. It's still far from over, okay? All right. We have this. I look at the numerator. Is there any like brackets, you know? Don't write this down, but I will do this on a scrap piece of paper so you know what I'm talking about. So let's say the top had had, like the y to the 4 had its own little exponent, you'd have to take care of that first before you start doing anything else. If you had 50x times, y x squared like this at the numerator, you'd have to multiply these out and get rid of the brackets before you do what we do when we collect like terms, okay? So you got to watch out for that. No negative exponents so far. Note, right? So nothing can be done upstairs, nothing can be done downstairs. I will look at the coefficients. The 2 goes in here 25 times, the 2 goes in here 1 time. So I've got that taken care of. It's just 25 in the numerator, no negative, okay? I'm going to collect like terms. x2 minus 4, y4 minus 7. All of that still to the 1/2. And let's do another line where we say what we got. That's x to the negative 2, y to the negative 3. All of that still to the 1/2. I'm still not done inside because I have negatives there. I'm bringing them both down. X squared, y3, right? So in order to change their exponents, right, the sign of the exponent, I bring them down. All of that to 1/2. Okay. We know that half, right? This to the 1/2 is the root, that's just 5. And this would be x to the 2 times 1/2 and y to the 3 times 1/2. So you're applying this exponent to all the exponents inside. So that's 5 over. This will just give me, right, 2/2 is 1. So that's just x. And this, unfortunately, ends up with a fraction, and that's all you can do. There's nothing else you can do. But this would be fully simplified like that. Are we good? Next, B. Let's do a one-liner. One-liner. Supposed to simplify this. We look at it, it's like, oh yeah, I'm just going to multiply across. Right? Watch that. This is only applying to this expression here. So you got to work that out first. Okay? So you have x cubed y squared times x to the 4, y to the negative 4 times 2 is negative 8. Z to the 1 times 2 is just 2. Apply first in this case. It's kind of keeping this trapped, right? You can't do anything with it unless you apply that first. So how about this in your notes? Times, times, times. Okay, that's what happened there. And now you can cross multiply like that. Same basis, right? X to the 3 plus 4, y to the 2 plus negative 8, and z is just Am I doing, yeah, z, there is no z in this one, so it's just z to the 2, like that. And that would be x to the 7, y to the negative 6, z squared. We don't want negatives, no negative exponents. Okay, so we just say, hey, well, that's fine. You just bring it down to the denominator. Let's do another one-liner. C. So this is just a one-liner. You notice that this one here has an exponent attached to it. So you need to free this before you can multiply across, okay? So we're going to do that. And how would you do that in this case? If you have a 6 there, it is 6 to the negative 1, x to the negative 1/2, y to the positive 3/4, like this. Okay. And here it gets a little tricky because of this. Okay. This has a negative 1, so it needs to go in the denominator. Okay, so we're going to do that. If you multiply the numbers, it gets you negative 3 over 6. We're going to bring the 6 down right away. And then it's x to the 3 plus 1/2, y to the negative 3 over 2 plus 3/4. Like that. Notice that this, I brought it down right away because you technically cannot multiply these two. They don't have the same base, right? If they had the same base, then you could maybe add the exponents, right? So I just brought it down right away, turned it into a, right? You can reduce these. 3 goes in here 1 time, goes in there 2 times. So it's negative x to the, what's 3 plus 1/2, right? You can do that on the side here. 3 plus 1/2, a common denominator of 2. That'd be 6 plus 1. That's 7 over 2. Right? So that's 7 over 2, like that. And then y is, you're going negative 3/2 plus 3/4, right? So negative 3/2 plus 3/4. Common denominator of 4. 2 goes in there 2 times, so that's negative 6 plus 3. That gives you negative 3/4. Like that. All of that over 2, right? Because that 2 comes with you. And then you have negative x 7 over 2 over, we're going to bring this down, 2y 3/4. This is a very ugly result, but as long as you apply everything consistently, it should work out. Let's try something like this. D. Write this down. As you can see, none of these in the numerator or denominator, there's anything that you can do. You can't collect like terms anymore. It's already been simplified. You can't simplify the coefficients, so that's it. So before I would apply this and get rid of that negative, I would first clean up inside and get rid of the negatives in here. So I would say 3 over 2 m squared and 3, all of that to the negative 4, like that. So basically, I'll make a note here. I'll just leave it at that. And then apply that one by flipping the whole thing. The whole thing, everything that was in the denominator comes up. Everything that's in the numerator comes down. And then you apply the power of 4 to everything. Okay? So it's basically 2 to the 4, m to the 8, n to the 12, and it's also 3 to the 4. Okay? And this is really 16, right? M to the 8, n to the 12. This is really 9 times 9, which is 81. Right? And then that's it there. One last example before we go. And I'll give you some of the homework. here you have a bracket within a bracket. So take care of this first here. Okay. What I would do in this case, I would just distribute this across whatever is there. Instead of flipping it, I would just distribute that exponent. So C -1 times -3 is 3, and D has an exponent of -1 like that. And then you have C squared and D. All of that is still to the -2. No coefficients to simplify, nothing like that, but I can collect like terms. So it's C to the power 3 minus 2. D, watch this, to the -1 minus the denominator and the exponent of the denominator. Okay, and that whole thing to the -2. And that is C and D to the -2. All of that to the -2. And that is, now I'm going to clean up the negative inside. C over D to the 2, -2. I'm going to flip this to turn that positive. And then I'm going to go D to the 4 over C squared. That's your final simplified. Homework. Let me just make sure I get this right. 241. Seven to 11. I'm sure some of you are going to go to 7-Eleven to get a Slurpee, right? Just because of that. And 14 to 17. Let me just check. Identify error, 17. Very good. I'll give you 19 as well. Find errors. I realized I just actually did a few questions from your homework already, so there's your bonus. Before you go, okay, there is this one handout that I would like you. Did I assign this already? This is. Do you recognize that? Okay, this has an answer key at the back. And so the problem with the homework is it keeps it pretty basic, right? So I would say plus handout. And I don't know what to call this one with, but this is the handout I'm referring to, okay? So make sure we have